Yes. Coming from the IP address. IP conflict. All right. Fine. So we can, right? First, remote image. All right. So let's start with the project thing. The first thing about any project is planning. You plan it well, you'll execute it well. All the projects that usually fail is because of pure, what we say, not properly planned projects. During this phase on your repository, the DevOps Cloud repository, you have a mini page, mini project folder. That you have a page, mini project.md. This is where we're going to update everything as we proceed along. I did not give the full project structure intentionally. This project is about you thinking and playing. I want you to work along with me and create. See this image, alright? Open that image on your screen and just go through it once. That's a basic outline of the project. It's just outline. As we progress, we're going to change everything on the outline. Anything that you don't understand on that image? Anything you don't understand? Any image or any tag? These are labels I put on each one of them. The hello stickers you are seeing. You want to draw it quickly on your notebook? The ALB is elastic load balancer on AWS. Elastic load balancer. ALB is one type of elastic load. This is application load balancer specifically. We will talk about it when we go deep into each one of these components. What you do is quickly draw this diagram. Look at it and draw it first. Then don't look at it and draw it again. This triangle here is Git. I missed that label. The triangle is Git. On the leftmost side is Git. From Git goes to GitHub, the code. While drawing this diagram, pay attention to the title of the project. And this is what you are actually building. Look at the title. That's what you are trying to build. It's really important you understand what you are trying to build. What happened? Maybe was it? It's not working. Internet is not working. We're not able to connect. Room 1 is connect to room 1. Is it not working? What does it say? Then connect to your mobile data. Connect to the internet. Here, in room 1. Connect to room 2. Link to. Okay. Disconnect it and connect to room 2. That's enough. Open up the space. Everybody has problem with it? Restart your system. Very quickly restart. So do one thing. Open this on your mobile and directly start the podcast file. Go to Google, search for GitHub encode edit. You will see the encode edit.io. Can I write 2 times? Let's see what we are trying to build and what we are missing in that. What we are trying to build is an application accessible from internet. That's your application. You have a user who would want to access your application through the net. So everybody probably has a laptop and somebody hits a URL, http website.com, comes here and it enters your application. Now the entry point is the elastic load balancer. This entire thing you are trying to build on AWS. So the entry point is application load balancer. This is a type of elastic load balancer. The keyword is elastic. It means it can manage the load by increasing or decreasing in number of instances it handles. Let me put it this way. Let's say you have 10 users, it can handle it. 10,000 users, it can handle it. 10 lakh users also, it can handle it. The way it does is, elastic load balancer, this is a software, let's play on it's an Apache server internally, but it is managed by AWS. And for us, we don't see anything except that there is a URL, that's what. Now internally, what happens is, it creates a lot of EC2 instances. And on each EC2 instance, you have either Nginx or Apache. They use Nginx internally. So when the load increases, the number of EC2 instances that represent your ALB increase automatically. And when the load comes down, it comes down. Alright? Now all that thing is managed by AWS. So for us, as a user, we don't have the headache of making sure your ALB is up. It's taken care by the AWS itself. That's the reason it's called elastic. Now what is application load balance? If it is application, what else is there? There's another one, network load balancer. Now this is where the distinction is. Pay attention here. This is the confusing one. This is called L4 layer. This is called L7 layer. Both are load balancers, but one is L4, other one is L7. Now what are these layers? How many of you are from computer science? We have a TCP stack. If you see this door, pick up anything, any image is okay. For posting these images. We can open these or we can go to directly Google and search. Alright, let's talk about this. Now this is the stack of TCP/IP. Is how a request travels from one system to another system. This is part of networking. Usually you study in your graduation if you are from a computer science graduate. If you are not, still okay. But that's the bones behind this whole TCP/IP network, internet, everything you are saying. What you are interested in is the layers here. A physical layer is basically your cable. Then you connect cable, right? Then your data link layer is your MAC pin, or your portable jar is called, right? Then your network layer, it passes through. Then your transport layer is where the IP gets added to your data, alright? Then your this is the part of sub-layer. Then comes your application. So when a request travels from one system to another system, alright? Application gives the data, and the system keeps adding another packet to it. Core data, then transport layer data, then IP address, then MAC address, all those things. Alright? So that's how it travels. That's not really important. What is important here is whether the load balance, if a request travels from one system to another system, in this case, it is traveling from here to here. Alright? If it is a layer 7 load balancer, it can recognize HTTP versus HTTPS request. Alright, that is layer 7. So here the major distinction is HTTP and HTTPS, not versus. Whereas layer 4 cannot recognize HTTP and HTTPS. What it means is, let's see what it means. So a layer 4 protocol or a layer 4 load balancer, let's say you have two systems. Alright. You're sending a TCP/IP. One application on this one is sending a request to another application on this one. When we say application, these are all processes. Let's say here is an Apache server, here is another Apache server. One Apache server, how do they send requests? HTTP, IP, colon, port number, slash, abc.html. So this Apache server, our browser, is asking this Apache server to give this page. Alright. Now in this part is the layer 4 network. This part is layer 7. Means this guy understands what HTTP is. This system will not understand. Means when it reaches the system, operating system, at your RJ45 jar or at your IP level, this layer, network layer, does not understand anything about HTTP. All that it cares about is IP, okay, that's me, and port number, where should I send? Send it to this. That's it. So the question here is whether you want this guy to load balance something or you want this guy to load balance. Let's say there are 3 Apache servers on this. If you are using layer 4 load balancing in this one, your network part receives your request. Usually it's again a process, init process or something. And it divides it across the Apache servers based on IPs and port number. That's all. So what it understands is if a request lands on port 80 or if it comes for port 80, send it to one of these 3. These 3 could be running on 8080, 9090, 1010, 1010. So what you have done is you load balanced at layer 4. Alright? So based on the port itself, you load balanced it. All that this guy cares about is okay, if the incoming port is 80, send it to one of these. Alright? Now as opposed to this one, let's say this guy does not understand anything. Alright, you are not trying to do a layer 4 load balancing. Instead, after this receives, you set up another Apache server here. Apache server understands HTTP. Then behind Apache server, you have set up other Apache servers. Now you are telling Apache, if the request is HTTP, send it to this one. If the request, HTTP abc.html. If it is /abc.html, send it to 1. If it is /xyz.html, send it to 2. If it is slash this, send it to 3. You are load balancing at the application part, not at the network part. So the major difference you will see is, if you have a URL, HTTP IP port slash, let's make it a little more complicated. abc.html is one website, xyz slash xyz.html, another website. Alright? If it is a layer 7, which means any Apache server or ALB or anything, it can look at this thing, because this is the HTTP part, and redirect it to a separate Apache server. So layer 7 load balancing is application aware, whereas layer 4 or network load balancer cannot really understand these parts. All that it cares is this. So layer 7 happens after layer 4 usually. Now depending on what you have or what you need, either you choose an application load balancer, which is layer 7, and it can redirect based on your URLs. A different URL coming, send it to a different HTTP server or another server, anyway. Alright? Basically, it recognizes the URLs. If it recognizes the URLs, you have a layer 7 load balancer. If you don't care about these things, you use a regular network. So you can have a setup where the first thing is layer 4, TCP/IP IP port. Alright. Then behind that, you can have layer 7. Alright. Behind that, you can have application Apaches. Now this is a really complex setup. And as I said here, you are getting 10 lakh requests. Alright? Or 9 lakh for convenience. Now the layer 4 load balancer will redirect or balance it across 3. How many requests each one will get? 3 lakhs each. Then layer 7 takes based on ABC or XYZ. Now the layer 7 is pointed to everything. Assume all of them are either they have XYZ or ABC. Both are deployed onto all of them. So what is happening here is, once it reaches layer 7, we are essentially looking at the URL. The same way here. This is layer 7. This can also look at URL, XYZ or ABC. Send it to one of them. Again, here also look at XYZ, ABC. Send it to one of them. The reason why we do it is, layer 7 cannot handle too much load. Layer 4 is really fast, because that is happening at your network layer, almost at a physical layer. Now once you are inside a physical layer, this layer 7 is always a software. It's just like, using physical cable versus a Wi-Fi. The Wi-Fi can never catch up with the physical cable. Where data transmission always is much faster than physical cable. So here, layer 4 handles the network level, TCP/IP protocol only. Layer 7 load balancers can recognize HTTP and HTTPS. Alright, now you will see this in a lot of documents. All the documents, wherever there is elastic load balance, even in our ingress is only layer 7, it cannot do layer 4, the ingress controller. So this whole picture can be summarized into two things. You have either layer 4 load balancer or layer 7. Now when you write it, usually this is how you write it. You know why? A TCP stack is represented like this always. This is physical layer at the lowest. 1, layer 2, layer 3, layer 4, layer 5, layer 6, layer 7. That's how the TCP IP everybody learns. Alright? That's how, whenever you write something, a layer 7 will be written at the top. Layer 4 is at the bottom. It's just like layers. You visualize it, one on top of each other. And in all the books you see, this is how the TCP IP stack you learn it. Alright? So that's how people remember it. Anybody who is into computers or anybody who is designing it, they always take that picture and they reference it. So that's why when you write it, L7 you write at the top, L4 you write at the lower. So L4 is your network load balancer or layer. This is your presentation or application layer. This is as per the TCP. For us, what we are interested in is this can recognize HTTP and HTTPS. This cannot. That's it for you. And when we say HTTP, HTTPS recognition means in your URL, you can have these kind of blocks, and based on the URL, you can redirect the request to anywhere you want. Alright, let's come back to this thing, our original diagram. So what you have is an elastic load balancer to receive all your requests. Now we just said elastic load balancers are A and Bs in this case are not really good with your handling traffic. Then why did we use ALB? You are not really expecting crushing traffic kind of thing. If it is crushing traffic like Facebook or Google, you first will have a network load balancer first and then have it redirected to ALB. In a regular normal operation, ALB is usually more than enough. So what happens in this case is our user sends a request to ALB. So ALB, what it does is basically it redirects the traffic, alright, based on your incoming request. Now when ALB comes in, this way you have a public IP or public DNS. This is the only thing that is accessible to the outside world. Right. Now this IP or DNS is usually linked with a website. Let's say mywebsite.com. So people will hit this mywebsite.com, alright, they land on the public IP. That's part of the DNS. Now once you reach the public IP or the ALB, now the ALB has to send it to our production. Your application is deployed to production. Let's say you have a Kubernetes cluster here, production, which has n number of worker nodes. In our case, we have 2 worker nodes. And obviously, there has to be a master node. This is worker 1, this is worker 2. I assume the application is deployed onto the pods. Now the request that this user has sent first landed on ALB, and the ALB can send it to the pods. Let's say we are exposing these pods as a service. So you have service 1 or service 2 and service 1. This is /ABC service, this is /XYZ. Now I listed these pods on both the nodes. just to make sure they can be anywhere. It's also possible that both of them are on the same node also. Alright? And this makes your image a little messy, but that's what is actually happening. So let's redraw this a little bit to make it more visible. So we have 1, we have 2. So this is one application exposed as a service. This is another application also exposed as a service. Right. Let's call it this one slash ABC service S1. This is slash XYZ S2. Now, when a request lands on the elastic load balancer or application load balancer in this case, can the application load balancer send it to either XYZ or ABC? Does ALB has that capacity? Application load balancers are layer 7 load balancers. Network load balancers are layer 4. What's the difference between these two? L7 can redirect the HTTP ACDPS, which means it can recognize XYZ and ALB. But it can always what happens now is for each service we need to attach. If you are exposing this service as what are the 3 types of services? Cluster IP, node port, load balancer, right? Now, even though this elastic load balancer can redirect everywhere, AWS does not give us any choice. When you expose a service as a load balancer service, it automatically creates an ALB. So what happens here is, instead of having one ALB for all our services, you end up having lot of ALBs. Each one for one service that you are exposing as a load balancer type. Now the problem with too many ALBs is each ALB has to be attached to another website URL or something. And these are costly, ALBs are. So a practical solution is, instead of having one ALB per service, let's have only one. Let that guy pass it on to somebody called an ingress controller. Ingress is incoming. Ingress meaning is incoming. So you have incoming controller, ingress controller. Let this guy decide whether to go into ABC or XYZ. So this is also acting as a ALB. This is also a layer 7. Alright? So instead of having too many ALBs on AWS, you have an ingress controller and ALB sends it to the ingress controller. Now, depending on the load you are receiving, the ingress controller is also deployed as a pod. Now, depending on the load you are receiving, you can have one controller or many controllers. So, what you have is an ingress controller pod, which is also exposed as a service, a load balancer type. That is only attached to AL. So even though that image shows only one pod for ingress controller can grow up and down. So the number of replicas you will change based on your need. So what you have is, you have services, only one of those services is exposed as a load balancer type. Everything else is either node port or cluster IP, because This service, your ingress controller service, is internal to this cluster. And it can reach all these cluster services even if they're on cluster IP type of service. Now that helps in terms of security. You are not exposing any of these services or pods to the external world. They are all protected kind. Now that's one thing that all these clouds sell as a selling point. They say your cloud is very, very secure because nobody has access to them. Not even us. Only this program has access to us. And now this is well protected. Alright? Now let's see what next. So your request lands on the controller and the controller has rules. What are those rules called?
Ingress rules.
They are ingress rules. So you have ingress rule 1, ingress rule 10, 2, 3, 4, 5, 6, 7, 8. All these ingress rules are defined in the HCD database of your master. So when you set up your ingress rule, basically you're setting up in this one, and the controller, whenever a request comes in, the controller verifies your incoming request with all the rules. One of these rules says, if the incoming request has XYZ in it, send it to service 1. The service 1 is a cluster IP, isn't it? So all that it is doing is sending the request to an IP. And the service or the cluster IP knows how to redirect it to the incoming pods. If one of these pods goes down, a new pod, let's say, got created here, the cluster IP still remains same. The new IP of the pod will be updated into the list of pods in cluster IP. So for the ingress controller, it doesn't really matter. The cluster IP is never changing, even if the pods are changing. So if you can visualize a highly unstable Kubernetes cluster, we're talking about a very unstable Kubernetes cluster where pods are dying really quickly. So which means the cluster IP list is changing really, really fast. Even then, the ingress controller never knows about it. You understand? That's the reason Kubernetes is so popular. A lot of things could be happening on the background. From a front, nothing really, it's not seen at all. It's just like, a cricket match is happening inside a stadium and just you are standing outside it. A really noisy cricket in a India-Australia match is going on. Really, somewhere in Bangalore or Mumbai. You know the noise. But for somebody who is standing outside, it's really quiet. It's really, really quiet. Nothing is happening, right? So the same thing. From an outside visual or an outside view, all these Kubernetes pods going down, going up, it's not visible. That's all covered by using a common IP or something. Now this is called abstraction. It's a very important word in software. You abstract all the complexities by covering it up with something. In the example that we talked about, right, the cricket stadium, the abstraction is the wall around your cricket stadium. That abstracts everything inside it. So for you, it's just a round wall. So the cluster IP abstracts the complexities of pod, like pods will go down, pods will go up. Whatever happens, when a pod goes down, the IP will be removed from the list of cluster IPs. Cluster IP is nothing, it's just a list. So cluster IP is pod 1, pod 2, pod 3, just a list with IP. Each pod has an IP. So this list keeps changing, whereas cluster IP remains same. Now this whole thing is handled by a quick proxy. So what we have here is a request lands on the ingress controller. Ingress controller verifies and matches all the ingress rules against the incoming request and sends it to the corresponding cluster IP service. Alright? Now here you can have as many services as you want and define those corresponding ingress rules. Alright? That's what we have here. Now, this whole thing has to be deployed. Your project is about CI/CD pipeline, right? This is not even CI/CD pipeline. That's the end of it. That's what the user, that's what you're giving it to the user, your product. You're saying you are building this product. So everything behind it is your job. Let's see how you build it. Now, you have to deploy application 1, you have to deploy application 2, which is /abc and xyz, let's say. Alright. Now, this whole process you have to do using your CI/CD pipeline. Let's say you have ABC application and XYZ application. Where is the code? So you have the developer, you use some Git, sends everything to GitHub. This is in the cloud, right? Then you take the code into Jenkins, you build. Now, because we are talking about Kubernetes, the build has to be a Docker image, because only Docker images can be deployed to Kubernetes. Now, we are not really talking about WAR or a zip file. Remember, this project will not have all the things that we talked about. We cannot insert everything in here. The one major component missing in this whole diagram is, can you identify it quickly? Ansible. Ansible, that's perfect. We cannot include Ansible anywhere in this. For Kubernetes, Ansible is pretty much outdated. If you are purely into Kubernetes, you don't need Ansible. But not all projects are purely Kubernetes projects. You always have an old application, you always have 10 other, 20 other servers. Then you are recently migrating to Kubernetes. So any project usually asks Ansible, not for Kubernetes. Kubernetes has a lot better tools than Ansible. And Ansible nowadays is reduced to handling only systems configuration. So unless you are managing some 10, 20, 30 systems, you don't really need Ansible anymore. Because our focus is mainly on Kubernetes, Ansible will learn it, but it need not be included into the Kubernetes. So it gives a false impression that Ansible can be part of Kubernetes. It need not. It is not nowadays. All Kubernetes projects do not include Ansible. But now look at it from a business angle. Ansible as a product is handled by Red Hat. Now Red Hat is owned by IBM. Now IBM is owned by this, nobody knows, Microsoft. Alright, so Microsoft has to make money. So what they do is Ansible, they keep pushing. So now you will see some Ansible modules which can create Kubernetes clusters, which can deploy to Kubernetes, all that stuff, but it's not really that good. So nobody uses Ansible for managing Kubernetes. Ansible is completely nowadays reduced to Linux administrators. So if you are a Linux administrator, if you have a large number of virtual machines that you are handling, then you will use Ansible. But if you are a Kubernetes administrator, you won't use Ansible. Most of the times, you will have a mix. You are not purely, completely Linux administrator. You are not purely Kubernetes administrator. All right. So usually you have 3 levels of supports in all projects: L1, L2, L3. L1 is basic monitoring. L2 is where most of the people are employed. L2 is mixed, means level 2 support. Right? So you do a restart or you do a quick troubleshooting, or you try to quickly understand what the problem is and fix it. Kind of. L3 are usually this is where your experts are. Now, when you are an expert, either you are a Linux expert or a Kubernetes expert. You don't want to be both, right? Because the work is too much and you have only 24 hours. You can't do everything, right? So Linux is pretty big, and Kubernetes is also pretty big and complex. So a person cannot work on both of them in L3 support at a time. People have skills, means there are people who are good with both. Usually when you are good with Linux, you can be good with most of the things, because all these things are built on top of Linux networking and file systems. But L2 is where you will see everything. Now in L2, because you are doing a mix of everything, that's the reason you have all these tools, Git, GitHub, Ansible. A lot of people know Puppet and Chef also. Then you have Jenkins. There is nothing in Jenkins. We have seen it. Nexus is pretty useless. Alright. Nobody installs Nexus nowadays. Everybody goes to Google Cloud or AWS Cloud. It's pretty cheap storage. Nexus is purely storage, right? You just store files over there. It's just like your G Drive. Google Drive. Google Drive gets 15 GB. And you go to Microsoft OneDrive, they give you 1 terabyte free of cost. And recently we purchased a Microsoft OneDrive family just for the office. It gives 6 members, each member 1 terabyte for 500 rupees a month. That's your biryani cost. We eat at least 2 biryanis a month. So it's pretty cheap. So nobody uses Nexus anymore. You put it now. Another problem. Earlier the problem was internet speed. That's the reason nobody wants to store anything in the cloud. Everybody wants to have it on your local storage so that it can be quickly fixed. Now internet speeds are really fast. Or you have 1 Gbps connection for about 5,000, I think. Pretty cheap. Even your Geo is pretty fast. Right? So we don't have any issue. So Nexus will be gone in probably the next 1 year. So stop using Nexus. It's just these are all fancy words. People keep bringing it up because you can't let it go. Just like there are certain things, from your childhood you can't let go of them. Or your old laptop or your old mobile, it's useless till you keep it. It's just a sentimental attachment kind of thing. But for products, you don't have to have it. So Nexus is going to go. You'll still keep it in your resume. Jenkins itself is pretty much gone. Everybody moves to SaaS. So you have Circle CI, which can do a really good CI. Travis CI, which can do a really good CI. Then nowadays you have Argo CD, that is doing really good. Right? With these things, Jenkins is pretty much gone. But you need it in your resume. The reason why people ask for Jenkins is they expect that if you know Jenkins, you can easily work on any of them. The concepts are same. Everywhere you have a job, you have plugins, and you run a job. That's it. Alright? So this is only for conceptual knowledge. So let's come back here. So Jenkins is where you are running it. And in our project, we're not going to have everything. So we don't have Ansible, and we are not doing any varchip deployments. Because this is Kubernetes, you need to have your Jenkins build an image. Docker image. The Docker image has to be stored somewhere. Alright? So we're going to use Docker Hub for it. Just like Docker Hub, you can store it on Google. Google provides a registry for images. AWS provides a registry for images. Azure provides a registry for images. Or you can have your private registry. And again, this is also a storage. Nothing more than that. So once you have the images, you need to deploy. Now the deployment requires a lot of YAML files. Take the example here. How many YAML files you have for ABC? You have a pod.yaml to begin with, then the deployment.yaml, then service.yaml, ingress.yaml. These are at least 4 here. Then if this has storage, you have volume, persistence volume.yaml, persistence volume client, PVC client.yaml. Storage class will come in this one itself. Then if this has configuration, you have config map.yaml. Then if it has a secret, you have secret.yaml. So you have a bunch of YAML files for any application. That's a given thing. Now obviously you need something to manage all these things, and what you are using? Help. And you are bundling all these YAML files into a help chart. The keywords are really important. Now because this is a chart, it's a tar file, compressed. Now any file has to be stored somewhere. You have a chart repository. It can be an Access or another chart repository. We will see that. So what you have is a tar file, zip file of all these YAML. Now these YAML files will refer to the Docker image, especially the pod YAML. Inside a pod you have a container. A container needs an image, doesn't it? So the images are stored in Docker Hub. So you're going to tell the image URL inside the pod YAML file somewhere. Alright, so we're going to build the Docker image. Where do we build the Helm chart? That also has to be created somewhere, right? Where do we create it? Where does it come from? We do it or the developers do it? It's the developer who has to do it. We don't know anything about it. This is the actual application. How he wants to expose it. So Kubernetes is not just for administrators. There is actual Kubernetes developer. So they have just like Java developer. There are Kubernetes developers, which means they can still develop a Java container, but they should know how to convert it into an image, how to create a Helm chart for it, and then how those things are internally related. All these things have to be learned by a developer also. So here you get a chart. Now the chart code also gets downloaded by Jenkins. Alright. Now here charts can be built by Helm. Helm not only deploys it, it can build a chart also. Helm in it. Now the most important file is chart.yaml file. Then values, requirements. Then you have templates. This is where all your list of YAML files come. This is a general structure of chart. We've seen it already. Now this whole structure has to be built by Helm, but it needs the YAML files. So what the developer does is, a developer pushes the YAML files here, and we will ask Jenkins to use Helm to create the chart. So Jenkins itself will not do that, but in one of our build stages, there are all stages, right? Jenkins is all stages. So you have clone the repository, compile it if required, then you have a build. So there are two build stages here. Build one Docker image and push it to Docker Hub. Fetch the URL of the image, then build Helm. This is also another stage. So by the time it reaches Helm build, it already has the Docker image URL. Alright? And the previous step, it pushed it over there. And here it calls Helm package manager and all the commands related to Helm. So how does Jenkins calls Helm? We install a Helm plugin. Jenkins can call anybody if there is a plugin. So we're going to install Helm plugin on Jenkins so that Jenkins can call Helm. And Helm will build the chart. After Jenkins calls Helm and it builds it, what Jenkins will do with the tar file? It will send it to chart. So you have two build stages. Build one is to build your Docker image. Build two is to build your chart repository or your chart. Chart is just a tar file, right? It's just a bunch of YAML files. The file size is also very small. Clear so far? Okay. Now Nexus is another component that we have put in. Most likely we're not going to use it. Or a chart repo will be replaced with Nexus. I'm just looking for a SaaS-based chart repo. We find it, we will use it. Otherwise, we'll use Nexus. Whatever is better. All right. Now, this whole thing is a Kubernetes cluster. Now, let's see where we are going to build. And this is what we are going to build. All right. This is what part. This is what I'm going to do all this. The next question is, where are you going to do this? On your laptop, or on AWS cloud, or Google Cloud, Azure cloud, or a mix of everything, or some other cloud you have virtual machine, or on our own jump server that we have. Where are we going to build it? That's when you have to start executing command, right? The first thing is, where do I connect? What's the IP that I connect? This is all nice, image is good. What's my first command? So where is your next question? So where are we going to build it? This part, let's say, we're going to make building Kubernetes easy. We already talked about it. I already said nobody is going to build Kubernetes clusters anymore. Kubernetes is so popular, or they made it so popular that everybody wants you to use an existing or a managed Kubernetes. Look at all the service providers. You have AWS Cloud, you have Google, you have Azure, you have a lot of 10 different cloud providers. You have DigitalOcean, you have Linode. These are 5 major cloud providers that pop in. 3 you already know. What you don't really know is, what you don't normally list out is, there is an IBM cloud, nobody lists it out. There is an Oracle cloud. They also provide these things. These are the 5 top. Then you have DigitalOcean and then Linode. They are not really that commercial, but now all these cloud providers, they give you managed Kubernetes service. Now what does that mean? What does that mean by a managed Kubernetes service? What it means essentially is, they handle the master file. If you are setting up a Kubernetes cluster, you need a master and workers, right? Let us say, we will set up the master file. Everything is ready. You just choose your workers. And you pay us only for the workers. Master is 0 cost. In DigitalOcean, master is 0 cost. In AWS, master costs you $0.10 per hour. So that's for 1 day. How much it is? $2.4. What? How much is a dollar? About 75 approximately now. How much is coming to? 2.5, let's say. 150 plus another 200, let's say. So that's per day. Per month, 6,000. That's pretty cheap. for a company. We're talking about companies. All right. So what everybody does is, or what they promote is, you take it up to manage Kubernetes cluster. You just pay us for these things. It's going to become more and more popular, and because setting up a Kubernetes cluster is really complex, no project manager wants their team to spend all the time in setting it up. Now, when you say set it up, let's say somebody comes to you and says, you are software engineer, they come to you and say, set it up. Right? You are really struggling to set it up. It's really complex. Sometimes it doesn't work. Complex in a sense, not that you don't understand it. It does not work at all. It has so many bugs. You get one bug, you get somebody, some other bug, you get some other bug. Even if you are installing on the same virtual machine. If you run it 10 times, you get 10 different errors. On the same virtual machine. You have launched the virtual machine, same settings, you tried first, one error. Okay, you destroyed it, launched it again. Same virtual machine, you tried it again, you get past that error, you come across a new one. So Kubernetes setup is not really that simple yet. Now what they've done is, they've taken out this part, setting up the master part. They set it up for you. Manage Kubernetes, right? Now all that you have to do is join your worker nodes to the master. So what we are going to do is, we are going to use one such Kubernetes. And because we want to use what is popular in the market so that we can get a quick job, we're going to use AWS Managed Kubernetes Service, Elastic Kubernetes Service. That is AWS Kubernetes. Kubernetes has another service called ECS, Elastic Container Service. That is also to handle containers, but we're not going to use it because you are saying you know Kubernetes. Which Kubernetes you know is AWS EKS. So this whole production of your Kubernetes is going to be on your AWS. So we're going to set up a EKS cluster. And this is where we will deploy your application. All right, so that's our AWS. Now what about the remaining parts? So you have a Kubernetes cluster, that's where you deployed everything. You are restarting, stopping, you are deploying, undeploying, releasing. You are doing all kinds of maintenance on this Kubernetes cluster using your AWS. How do you manage this whole cluster? On AWS, you have AWS CLI. You don't do stuff from console. Not really useful. There will be about 20 commands on AWS CLI that you have to know. kubectl, anyway you know it. So you use both AWS CLI and kubectl to manage it from your command prompt itself. So that part is taken care of. At least we know where we're going to build it. What about the rest of things? Git, none of our business, that's developers. GitHub, we have GitHub account, so we will put it on to the cloud. So all the repositories will be here. Docker Hub, luckily it's still free. Chart repo, we will decide whether we are going to use Nexus as chart repo or something that is available online. A popular one is available in JFrog. This is just like Nexus. We have seen that. Or we can use a Google chart repo, GCR. Alright, our Google Container Registry. It's called. You can use Docker Hub and chart repo. Can we use S3 for chart report?
Yes.
We can. We can do that one. We'll see. Then Jenkins. Nexus we will decide later. What about Jenkins? Because we are trying to do everything on AWS, can we do it on a EC2 instance? Yes. Or because you want to reduce the cost, can you deploy it to a Kubernetes cluster? This is something that you want. Practical. Can we do that? It's just a software. It's a Tomcat server. Any software can be deployed to a Kubernetes cluster, isn't it? Can we have it?
Yes.
Can. But that will confuse everything because we are saying that this is your production. This is where everything goes at the end. So we need to have a beginning. You can have a Kubernetes cluster here and just deploy Jenkins. That looks really posh. You are running your Kubernetes also on Jenkins. So you're going to say your Jenkins also runs on Kubernetes. So your whole world is Kubernetes. You just set up a simple, very simple. You just need one pod, that's all. We'll see. If this does not work, or if it's costing us too much, we can always have an EC2 instance and run Jenkins just like everybody else. Common man stuff. This is celebrity stuff. All right. All right. I'll just quickly list out what we're going to do roughly, and then we can change it later. Any questions so far? Any questions so far? So now you got some clarity on what you're going to do and where you're going to do it. The next question is how you're going to do it. That's what we are planning. All right. So that's a list of topics, we have a list of tasks that we need to do to build this up. So let's start with. First thing, you have to run a GitHub. So you need a GitHub account. Then you need a Docker Hub account. We will do it in the same logical order. So you need a Jenkins server. So you're going to say create GitHub account, build Jenkins server, create jobs. The jobs or pipelines have to be created. All right. Then create Docker Hub account. Create chart record account. Sorry, Nexus or any other thing. Then run the jobs. So this will build Docker image and build Helm chart. After you run the jobs, you have a Helm chart. Right? Which means you have the application ready. Now once you have the application ready, you need to deploy it. How do we normally deploy to Kubernetes? Helm again. You can have a tool, complex tool here, like Argo CD or something, CD tool, but we're going to make it simple. You can run Helm directly on the master by connecting to the master. Or can we set up a Jenkins job to deploy to Kubernetes cluster? It can do deployment also, right? And deployment is just a command.
It's easy.
You run kubectl, or luckily we have Helm. Helm can deploy to Kubernetes clusters. We know it. So Helm can create jobs. It can also deploy. So all that we have to do is run a Jenkins job to deploy. Now run this job internally calls Helm again. So we want to say run a Helm job. So run Jenkins Helm job to deploy the app. But before we do that, we missed a couple of things. You have to build the k8s cluster. So this is 7, this is 8. Right? Now this whole thing you have to do it from your laptop. If you are using browser to do this stuff, fine, you'll use your laptop. But if you are using your command prompt, alright, kubectl or something, you need a virtual machine to do that. Isn't it? You can't run it, or you can run it on your command prompt, but there's more like Windows installations, which you don't do now. So we need a simple admin box, admin instance. It could be a nano EC2 instance, a very simple one, or a very small one. So this is where we're going to have everything. You're going to install kubectl here. You're going to install AWS CLI here. Everything. If you want to connect from one server to any of the other servers, you're going to do it from this admin. We can use the Jenkins EC2 instance itself as admin instance, but we want to separate it so that you understand what the functionality of each. So that's how in real time, everything is. We don't use Jenkins for anything other than Jenkins. We don't even log into a Jenkins instance usually. Alright? So admin instance is like your jump box. Alright? That's where you log in first and try to do stuff on individual servers. So you have about 9 tasks. Each of these tasks will have subtasks in it, and also some of these tasks can be done parallelly and they have to be done sequentially. We will come up with a detailed plan about it. So we know what we're going to do it, we know where we're going to do it, we also know how we're going to do it. Right? These are the tasks that we have to actually do to build this whole stuff. Now the question is, who is going to do it? All of you want to do it individually, or you want to do it as teams? If all of you have to do individually, there will be 2 problems. Your AWS account you will do, which means it's going to cost you. And you have to pay alone that cost. Problem 1. There's a bigger problem. If you are stuck, the chances of you getting out of that stuck is very less, because I'll have to deal with everybody in that. Now, as opposed to this, if you're working in teams, let's say 2-member teams or 3-member teams, the first thing is your cost will be divided. I'm assuming it's going to cost you about 100, 200 rupees. We are trying to keep everything, in no, free trial kind of thing. But the EKS, it's going to cost you a couple of 100 rupees, all right? Because you're going to run it for at least 5 to 10 hours. Even if you shut down everything after we are done with lab, but you'll still be working on it. So how do you want to do it? Teams or individual? And also, with the team comes the benefit of help. You always discuss when you are in a team. And also, when you are lazy, you can still tell him what to do. They'll do it for you. Like you have an assistant. You get lazy sometimes. You need help. You know everything. You don't want to redo it. Kind of, let's say you set up a k8s cluster. You know everything now. You don't want to do it again. You do it. I'll tell you what. You're using your friend as your assistant, but you won't tell it. You'll say, I'm helping you, I'm teaching you. So what do you want to do? Go as teams or go as individuals? Oh, so how many members per team? Now when you're setting up a team, the suggestion is whoever you are close with or who you are coming with, not just here, but when you're working together outside this class also, if you are part of that team, you can sync up easily instead of a stranger. So who you want to pick up your team members or teams. Expecting 3-member teams are good. We have 10 members, so one team will have 4. 4 is too much. There are 4, which means 2 members are not doing anything at all. 2 is perfect because 1 member cannot do everything. We will eventually push something to the other member. They have to share. 2 member is also. So we have 10, which means 5 teams. Don't think that's necessary. 3-member teams will have 2, 3, and then 1, 4. No. Yeah, I mean you have 2. You don't have choice. Okay. So 2-member teams. So who you want to team up with? Pick your team members, huh? That's fine. 2 or 3. If you're comfortable with 2 or 3, anything is okay. Just need a team. So who would 3 members want to be? Usually I'll go with the lottery kind of thing if it is a job-oriented program. But because this is, I want each of you to friends with each other, so you choose your partners. Huh?
You already said.
I can't decide it, who you are close with. For example, first to come together or sit together, they're already comfortable. You are comfortable. You both are comfortable. I know who she is comfortable with that. So it's more like you have to be already in sync so that you can work together.
2 teams will work as 3 members and 2 as 2.
Yeah, that's a good idea. Yeah. 3, 3, 2, 2. We'll have 4 teams. Yeah, that's a good idea. Very good. So 2-member teams. You do? Because it's just a team, it's not a competition. You're not fighting with each other. You do?
Yes, we do.
We do, okay. So we have 2-member teams, okay. 3, 3. We need strong and weak because those 2 are already fixed. 2-member teams. Let them live. You 3, all right. You 3 members. You 3 members. Mix it in a way that a strong member and not so strong member is part of the team. That way you will have better. Who thinks they need support? Raise your hands. Don't worry, we are all learning. And beyond all these things, I will be there with everybody. So don't worry. You still need a friend who you can ask all the stupid questions.
Yes.
No, that's true. That's true. When we are learning something new, we all ask stupid questions, and we can only ask it to the friend. Don't ask the trainer. That's the problem. I know the problems. So we need somebody who we can be really free with. Who needs support? Pranam, okay? Monica. So this, right? 3. So I need you 3 into, yeah. You 3 into move into 2 different teams. So we have 3. I have 3. 1, 2, 3. You 3 are okay, strong you are. So you 3 cannot be in a team. So I would say you okay, fair enough. So you, Vishnu, and I'll have to move Pranav into you. So you, Chaitanya, and Satish, Suresh, and Rizwan will be a part. That be okay? Right? I think you'll have to do a lot of work. These two are like strong. They two are strong, so you'll have more work to do. Okay with it? Alright, remember, I'll be with everybody, so it's not a problem. Right? So we have the teams.
We have to create a new account.
One of you have the account, that's fine. Only one account you are going to work. Any team member's account you can work on. And you have to agree to share the costs. If at all there are any costs. There will be about 200. Monica and you three. Fine, then both will work.
Sir, these four will work, they two will work.
Two, four.
I think.
4 and 4.
I think.
No, they want to do it 2. 2 is good. I want 2. Because both members will have an opportunity to actually work. 4 is crowd. 2 is a team. 4 members, I don't recommend 4 members. Especially for people who need support, 4 is not good. A strong member is going to do everything. That's not good. You won't actually gain anything out of it. Being part of the team. Or we can have a really challenging. All the weak members will, those who need support will form a team. I'll be with them. No, it's going on. Why you want to? If I have to decide, let's do one thing. So you two would lead, you two one team. You want 5 twos. Okay, fine. No problem. Don't worry. So then in that case, you both work together. That's best. Alright? You both work together, that's best. When I have any problems, you can talk to me. You can go to our home and work. Nobody's going to stop you. Alright? Then, you and Vishnu will work. Chaitanya and you will work. That makes sense? Siddharth and you will work. Right? Right? We all have strong and somebody who needs support. But now, there are some precautions when you're working in a team. You are part of the team, which means you have to take up the work. Nobody's going to give you the work. And also, this is the whole learning. Don't treat it like a job. A job mentality is, I don't want to do anything. I just want my salary. That's job mentality. You are paying here to learn, which means the more you work, the better value addition you are getting. Which means if somebody is not giving, your team member is not giving you work, ask and take that work, even if you are not able to do it. You can always tell your team member, I will do it, you tell me how to do it. You know everything, right, already? You tell me how to do it, I'll do it. So it's each member's responsibility to actually do stuff and try to understand it. Alright? So we have the teams, so just list out the teams.
With one account, k8s account, we can open in both laptops.
You can open it. Any number of people can work this. So we have, let's start from first. We have Arizona and Monica. Then we have Sailen.
Subodh.
Subodh.
Subodh. SUB. SUB double O.
Double.
Double SUB double O. Double O.
Yes. Oh, what does that mean?
Subodh.
Subodh, right? It is. Subodh?
Yes. Abdul Subodh.
Okay. What does that mean? Neighbors. He's Next we have Vishnu and Pranav. And we have Siddharth and Amar. Alright, those are the teams. Alright. We're going to have a competition among these teams. Alright. We're going to see, based on certain points, we will see. I'll give the list of points, we're going to evaluate you. Alright. Let's see who comes up first. We'll have a prize for that team. Alright, everybody else gets the knowledge, guys. Our team gets the prize. Alright, that's our team. Now, okay, we'll start working on it. All teams have AWS account, functioning AWS account. At least one member is more than enough. And if there are any problems with that account, we can always switch. And remember, it's not like one time, we should be able to do it. All right. Even if there are issues, we will quickly destroy it and recreate it because that's AWS. We can do it quickly. All right. There's no need to worry about making mistakes. Keep making mistakes. Let them all the basic stops that you come across normally when you're working something. Let those stops finish with this project. All right. And next thing, what I want is, I want you to come up with a plan. I'm going to stop it today itself. We're not going to actually get into tasks. I want you to build the k8s cluster today. And I think I'll give you some time to actually think over it and elaborate these steps. Part of this you already know. Part of this you don't. All right. Now each of these steps will have sub-steps. I want you to look at each of these things and list out the sub-steps for each. All right? And once you listed out sub-steps for it, push it to our Git repository. Not you done everything, push it to our Git repository. Can you do that? Yes. The challenge one repository that you have access to. Or create your own repository, push it over there, push the link to DevOps Cloud channel. Each team. All that you have to do is list out these things. Alright? You remember all that stuff, right? GitHub?
Yes.
Now this is the time you have to start work. Alright? So list out all these tasks. In each of these tasks, you will list out subtasks. Alright? Now if you know Markdown, that's fine. I'll teach you Markdown also. GitHub is Markdown. That what you're seeing here? This one? This is called Markdown syntax. Alright? There are only two things you need to know. You don't have to be really an expert at Markdown. You open a VS Code editor, alright? And you first create a Git repository on GitHub. You open VS Code, install Git on your Windows also, and do a Git clone of your repository, the new one that you have created. Alright? After you do a Git clone, you open a file, readme file or any other new file. The extension has to be a .md file. You've already seen it. So all our repositories, all files are .md extension. That is Markdown extension. It's like a .txt. Now the thing is, a txt cannot format like this. Means it cannot give you highlights, bold letters, images, these bullet points, again these headings, this kind of thing. It cannot give a text one. Whereas a Markdown syntax is like a Word document. Word document is a simplified form of Markdown. Means Word internally does the formatting for you. Right? If you are a programmer, this makes more sense because it's just like writing code for you. So I'm not sure you want this file itself. I'm not sure how it is. This file, right? This is that file. You're familiar with this one already. I think you have the blue interface. I changed it to white. This is Visual Studio Code Editor. This is that file. You're seeing the camel here. This camel,
Yes.
that is this code. And the 3 hashtags are, the number signals are, that will make this one bold. Next thing. Once you have 3 here, you don't have to have camel. You can simply write whatever you want and it becomes the bold thing. Then the 3 hyphens you see here is the horizontal break. This one. Then again, the same I'm using 3 hyphens again, makes it bold architecture. This is to attach an image. So the actual image is available here. And what you see, this is the alt tag. And the exclamation tells GitHub that it's an image. So when it looks at, so all that it is doing is, it is looking at the first column. And depending on what's there on the first column, it will format it. So again here, this is all this thing. Then the star mark is the bullet point. So all that I have used is only those 2. Pretty simple stuff this is. Right? So there are a lot of syntaxes or everything in GitHub. When they marked up, you have to remember 2, not even 3, 2. Everything that you want in bold, you put it in 3 hashes. And this should start from the column 1 itself. Can't have gaps. And after this, you give a space and you write whatever you want. That's it. Now, if you want a bullet point, you put it here with a star. That's it. You give a space. That's all you need. Only 2 things is all you need. The file has to be a .md extension. So what you are going to do is, you are going to create the Git repository, clone it to your local laptop, create a file, myplan.file, alright, and put your stuff here. Either it's a bold using 3 hashes, or it's a bullet point using a star. Alright? Thanks. That's it. Once it is done, you git add, git commit, git push. This is part of your project for Git. We did not include Git right in our project, so we're going to include that also.
Sorry, which type of file we should do that, sir? Visual Studio.
Just create a new file and extension only you change.
It's coming as plain text file or JavaScript.
Nah. Here, let's say you open a directory. Now, this is what we got to do. So this is your command prompt. Assume you have installed Git, alright? Which means you have Git commands working. Git is working here, alright? On that side, you have the repositories, all these repositories. On any directory, you click on right side and you create a new file. If you say test.md, that's it. The extension it detects automatically. That's it, done. Nothing. You don't say what type of file by selecting the type. By giving an extension, it automatically picks it up. This is what you want to do, but if you can't do all this stuff, if it is not working, still push a text file, regular text file. We want the work to be done, not necessarily in the exact same way that we are expecting. We'll fix it later, alright? So either you push an MD file or you push a regular text file. But what we want is a sub-steps. And I'll also push an actual file. I'll update the same thing that we are working on with all the sub-steps, and you will map it tomorrow. with my steps, and you'll see where you are missing or what you could not visualize. Now this usually comes to you again. The reason why I'm stressing so much on this one is people will ask you, usually your team lead, let's say ask you, okay, we need to build this, how long you want to take? That's a very simple question. How do you estimate the amount of time? Unless you know the task and how much each task is going to consume, you cannot estimate how much time it's going to take. These are the 8 tasks. Run it quickly. Each task, how long it's going to take, and give me a number.
Like if you are hands-on lead, I think 5 hours is fine to complete the project.
5 hours? Okay. Any other guesses? Everybody agree with it? I say it takes 15 hours. Prove me wrong. Why we gonna take 15 hours? You just agreed with whatever she said. That's not great.
We are at initial stage, so it may take time.
So 5 hours is more, you're saying?
Maybe I told you, when we are hands-on, like if we are at very good at all these steps, then we can do it fast.
We can do in 5 hours when we are good with it. That's what you're saying. And how long it's going to take now? We're not even starting. So now, how long it's going to take? Hours. 15? 20? 10?
10 hours.
10 hours?
10 to 12 hours.
10 to 12 hours per month. Now, how are you going to divide it in your team? Next year, you divide it. A lot of things can be done parallelly. By the time we finish the planning, you will realize what can be done parallelly. Then you should divide it between the members. And let everybody do their work. Alright? Okay, so when can I expect your files? Give me a time, deadline.
Only plan.
Yeah, just the plan. Just need a URL of your repository on that channel, that's all. EOD is a very fuzzy word. Everybody has a different EOD. My EOD is 2 o'clock AM. Oh, sorry, PM. Afternoon. You have a couple of hours home. No, I stopped working at 2 afternoon. So what's your EOD? 6 o'clock, 8, 10, midnight. For night shift, it's 6 AM. He's coming in night shift. So that's his EOD. Let's all agree on a common time.
12
8, 12 is
midnight.
okay. Weekend, you're saying. You have plans in the evening?
Yes.
Okay, so okay, let's look at the realistic time. Give me by tomorrow morning. By the time we are here, 7 o'clock. Tomorrow is Sunday. We all remember, right? You have to come here tomorrow, 7 o'clock.
Why?
You don't want class?
Yeah, we want.
We want to finish it quickly. We don't know what's going to happen. So once we start doing stuff, things will break down. Then, so let's not waste any time at the beginning. If it finishes quickly, fine. Or we'll do one. We'll have only a couple of hours tomorrow, not too long. You get up early, come here, we'll finish a couple of hours, and we have the entire day for your enjoyment. The work. Alright? So tomorrow morning, by the time we are here, we'll have your plan out. Ready? Fine. Any questions? Good. So you're going to give me the sub steps of all these 8 or 9 steps. Alright? Cool. There are no questions. That'll be all for now. We'll see you tomorrow morning at 7 o'clock. Thanks so much.